All right, good afternoon, everyone. How's everyone doing so far? Good, excellent, fantastic. Well, it's been a great first day here at Tech Days. This is, again, my first time to Finland. I'm having a good time. Just want to say thank you. If you were in the keynote this morning, my goal was to make sure that I did as little as possible to overlap with what I did this morning. This morning was very high level. This was really to talk about how we think about cloud. This time, it's about going deep specifically into Server 2012 and Hyper-V. I really wanted to get into understanding why we did the things we did, how we did some of these things we did, and give you some of the thinking that goes along behind it. Because I find that when you understand why we make some of the decisions we do, I think it really helps you understand the products and technologies and engineering tenets we do in delivering our products. This afternoon, I'm going to talk about scale, performance, and density, being able to address mission-critical scale-up workloads, storage, secure multi-tenancy, specifically in regards to networking, flexible infrastructure, continuous availability, and VM mobility. Before I dive into that, I'm going to take one quick moment, and this, I promise, this is the only time I'm going to talk about licensing, but I realized something recently. We made some pretty big changes in the licensing for Server 2012 to make it super, super easy, and in fact, it's a huge benefit for you, and a lot of people seem to have missed that. So I wanted to quickly take just a moment to explain this really quickly. In the past, Server 2008, Server 2008 R2, even going back to 2003, we've had different versions of server. We have had Windows Server Standard, Windows Server Enterprise, and Windows Server Data Center. And these three different versions usually had a variety of differences to them. Usually a number of different components, whether it was scale. For example, if you had Windows Server Standard, you could support up to 4 physical processors. That's 4 physical sockets. If you needed more than that, if you needed up to 8, you'd use Enterprise. And if you needed up to 64, you'd use Data Center. So there were some differences in scale. In terms of memory, you can see Standard in the past supported up to 32 gigs of memory. If you needed more than that, you'd use Enterprise or Data Center. Another big change was, for example, was in features and in roles. For example, in Server Standard, you didn't get clustering, or you didn't get some of the HA options like MPIO. So if you wanted failover clustering and MPIO, you had to move up to Enterprise or Data Center. And then finally, we also had virtualized guest OS instances. With Standard, you'd get 1. With Enterprise, you get 4. And with Data Center, you got unlimited. And it was, to make things even weirder, we licensed the first 2 per server and the last 1 per socket. And so one of the things that we heard when we spoke to you as we were doing our preparations for Server 2012 and our development, was we also heard you guys said, look, this is really confusing. Okay? If I go out and buy a server, I shouldn't have to spend all day trying to figure out what version of server I should buy. Say, for example, I want to buy a server. Oh, and by the way, it's going to have 4 sockets, but I'm going to put 64 gigs of memory in there. Which one do I use? Or what if I want failover clustering? What if I want et cetera, et cetera, et cetera? So we heard you loud and clear. So in Server 2012, we said, we're changing this. In fact, let's make this really easy, okay? So in Server 2012, first of all, there's only 2 editions, Standard and Data Center. Enterprise is no longer with us. Doesn't make any sense. Standard and Data Center. Now, what I'm about to say is going to sound really, really crazy. And in fact, I know no one ever believes me, so I have to repeat this. Server Standard and Data Center are exactly the same. I know you don't believe me. Roll your eyes. Go ahead. They're exactly the same. Scale, performance, capabilities, features, MPIO, clustering, it's all there. The same amount of it supports all the sockets you want, supports all the same memory. Up to 64 physical processors, up to 4 terabytes of physical memory, up to 64 virtual processors per VM. The clustering is in there, file server, remote access, branch cache, but it's exactly the same. Now, I know what you're saying. I hear him talking, but I don't understand the words coming out of his mouth. How can they be the same? Why would Microsoft do that? We wanted to make this really simple. In fact, there's only one difference. Okay, the about box is different. One says Standard, and the other says Data Center. But there's really only one difference. We wanted to make this super simple. So now when you go to license a server, there's one question you ask. Here's my server. Is this server going to be a virtualization host? Great. Buy Data Center. Get unlimited virtualization. If this is anything else, this is going to be a SQL server or an Exchange server or something that's going to run on the metal, buy standard. That's it. There's simply one question you ask now. What is the role of this server? Is it for a physical workload or is it a virtualization host? Makes it really simple now. Okay? So just want to let you know, it makes it real easy for everybody. So that's the one time I'm going to talk about licensing. Like I said, I'm not kidding. Standard, you get 2 VM instances. Data center is unlimited. So in fact, we gave you 1 extra one in standard. We gave you 2 as opposed to 1 in the past. So 2 is standard, data center unlimited, everything else is the same. All right, enough with licensing. Let's get to the good stuff. Scale up workloads. One of the things that we heard from customers time and time again was simply this. We want to virtualize everything, no exceptions, no sacred cows, as we say. We want to make sure that we can literally put anything on a virtual machine. Well, one thing I always have to tell people and remind them is scale isn't just more virtual processors. I don't know how many times I've heard this over the years. Jeff, Hyper-V in Server 2008 R2 supports only 4 virtual processors. When do you give me more virtual processors so I can run big scale-up workloads? Well, that's actually not the key to scale. Let me give you an example. If I've got a physical server here, and it's got 1,000 cores in it, you know, it's got 1,000 cores, but only has a gigabyte of memory, who cares? Okay? Doesn't matter. You're never going to keep those cores busy. Great. So let's put a terabyte of memory in there. That's fantastic. 1,000 cores, terabyte of memory, but if it only has 1 NIC and 1 spinning disk in there, again, doesn't matter. Never going to keep the system busy. Scale is not about more virtual processors. It's about balance. You have to look at the entire system holistically. Otherwise, you're just going to be playing find the bottleneck. Live migration should just work. No trade-offs. This is something you told us over and over and over again, and we heard you loud and clear. No matter what the size of the workload, no matter what feature it is, don't you dare take away live migration. We heard you. Performance must increase with cores. Now, honestly, that sounds almost silly. In fact, I felt silly even writing that in the slide. Of course, performance must increase with cores. But the reason why I put that there is because just by giving you more virtual processors, that doesn't necessarily give you more performance. Okay? I could have easily given you more virtual processors, but if I give you more virtual processors and your performance actually plateaus or worse, actually degrades, then we haven't done our job. And in fact, there's a whole bunch of engineering work we had to do inside the virtual machine to make performance actually scale. And I'm going to cover that in just a sec. And then finally, Jeff, I want you to virtualize those workloads considered non-virtualizable. Those workloads that do require access to my Fibre channel SAN, that require dozens of cores, hundreds of gigabytes of memory, and I want to be able, everything that I needed on a physical machine, I need to be able to bring to a virtual machine. All right? We heard you loud and clear. Let's start with scale. So to deliver massive scale on a virtual machine, let me kind of explain to you how this works on a physical machine. So forget about virtual machines for a second, just a physical machine. There's a concept called NUMA, non-uniform memory access. And the reason this came about is essentially back in the late 90s as we were moving from single socket systems, back then they only had a single thread of execution. There was no symmetric multi-threading or hyper-threading back then. We had a single socket and we started moving to 2 sockets. Well, the problem was you have 2 sockets that are both trying to access memory at the same time. They're both trying to access resources on the system bus, access I/O at the same time. And you have all this contention, and what happens is your performance doesn't scale because you're fighting for resources. So one of the things that was introduced was NUMA. NUMA is non-uniform memory access. And the goal of NUMA is to take processors and to take memory and actually group them together in nodes. And what you want to make sure is you actually take some memory and assign it to a processor, and you take some memory and assign it to another processor. And that's what actually happens when you put memory in banks. Banks are associated with processors, and so this actually groups the processors and memory together. The reason why you want to do this is because you want to avoid any contention. Also, you want to make sure that as you group these, you put them into nodes. And you want to make sure that the processor is actually physically close to the memory. You want to avoid traversing a NUMA node. Every time you traverse a NUMA node, you take a performance hit. And back in the olden days when we had front-side buses, boy, that could be really bad. Even today, with memory controllers on the chip and no more front-side buses, you still want to avoid hopping NUMA nodes as much as possible. So one of the important reasons why you want to do this is because for operating system or applications or workloads, when you do memory allocation, when you do processor allocation, you want to make sure that you're doing it for best locality. And what I mean by that is a processor and memory you want to reside in the same NUMA node. You want all of that to happen as quickly and as local as possible, and you want to avoid traversing those NUMA nodes. That's how it works on physical. All right? Let me show you and give you an example of what good NUMA looks like. Here's a 4 NUMA node machine. This is an optimal configuration. What you can see here is memory allocations and thread allocations are happening within the same NUMA node. Memory is populated in each NUMA node. Now, this is what non-optimal NUMA would look like. You can see in this case the system is imbalanced. Memory allocations and thread allocations are happening across different NUMA nodes. You can see there's multiple node hops. You can see that node 2 has an odd number of DIMMs. So for example, if you're trying to take advantage of any memory interleaving, there's a very good chance because you have an odd number, it's probably not going to be happening. Node 3 has insufficient memory, so it has to leave its NUMA node. And node 4 is actually the worst possible case, where there's no local memory, meaning everything it does is a access across a NUMA node. By the way, people ask me, Jeff, have you really seen this before? Do people really get systems this misconfigured? I'm happy to say it doesn't happen very often, but I've definitely seen it before. And usually what happens is someone will buy a large, big scale-up server, maybe 4 sockets, for example, but they'll kind of not spend a lot of money on the memory. And so they'll put a minimal amount of memory in there, and with the thinking that, hey, we'll add memory ourselves. And unfortunately, what we've seen happen is people put in memory like literally 1 bank at a time. So we'll see something like this where someone's got 4 sockets, but they put all the memory in bank 1, and the other 3 banks have nothing in them. And all of a sudden, their performance is just all over the place. It's inconsistent and trying to figure out what the problem is. So luckily, Windows has a bunch of things that are in there that will tell you, whoa, it looks like NUMA is completely misconfigured. So you want to avoid that type of thing. So we see less and less of it, but you certainly want to avoid this. So how does this relate to virtualization? Well, this relates to virtualization because, like I said before, we only supported 4 virtual processors in a VM. Now we support up to 64 virtual processors in a VM. To be able to do that, we have to add intelligence inside the VM. And so we've introduced guest NUMA. And the way guest NUMA works is we actually present a NUMA topology within the virtual machine. And the way that works is when you create the virtual machine, we look at the underlying physical hardware. And we go, oh, this has 4 sockets, and this is how the memory is configured in those sockets. So when we create a virtual machine, we want to map the virtual machine resources as closely as possible to the physical topology so you get the best scale in a VM that maps to the best scale and the best NUMA topology on the host hardware. And what's you need to understand is when you install an operating system, Windows will look down at the NUMA topology and understand that. When you then install an application, whether it's SQL, whether it's Oracle, or even IAS 8 in Windows Server 2012 now is completely NUMA aware. And because of that, in fact, you'll see IAS 8 scales like you've never seen before with Server 2012. So when you install the workload on top, the application will call down to the operating system. Well, that operating system is running in a virtual machine. The VM is presenting a NUMA topology that comes from the underlying physical. So the important thing is that you're seeing that NUMA topology bubble all the way up into the workloads running inside it. And so this gives you the best locality for virtual resources in terms of physical ones. I also want to point out this is policy driven. So the good news is we do all of the work for you. Okay, like I said, when you create a virtual machine, we actually look at the underlying hardware and do the right thing. Now, if you think you're smarter than us, we actually have all the knobs and switches in there if you want to go and play around with NUMA. In fact, I'll show you this in a little bit. If you want to go inside and play with NUMA and make changes to the topology. But 99 times out of 100, you're never going to do that because we've done the right thing. So you may be thinking, okay, Jeff, if those knobs and switches are in there, when would I use it? The one scenario we've come up where you'd want to actually set your own NUMA topology is if you needed to live migrate VMs between different physical servers with vastly different NUMA topologies. So say, for example, I needed to live migrate a VM that was running on a single socket with 8 cores to a physical machine that had 8 sockets with 1 core. Okay? Now, in reality, boy, that's probably going to be extremely rare. But we also wanted to make sure we future-proofed it and made sure there wasn't any situation that we couldn't think of that someone would need it. So we put it in there. But by default, you don't need to do anything. You create the VM, we automatically look at the hardware, create the NUMA topology, and do the right thing for you. And because of that, we're able to deliver such massive scale. 64 virtual processors, a terabyte of physical memory, up to 320 logical processors on the physical side. Massive scale in terms of clusters, massive scale in terms of VMs in a cluster. 8,000 VMs in a 64-node cluster. And again, because we did NUMA, NUMA is an industry standard. You know, it works on down-level operating systems like Server 2008 R2 or even Linux. Okay, so just so you understand, hey, this is industry standard. As long as the OS supports NUMA, it's going to work on top of Hyper-V. There's no special magic. NUMA is NUMA. And in fact, here's a 64 virtual processor SQL workload, OLTP workload running on SQL, 64 virtual processors, and a terabyte of memory assigned to the VM. So we could support the biggest, baddest workloads out there. In addition, we had a third party do a whole bunch of testing. ESG did their own testing with SQL, running OLTP workloads, and the whole goal was we wanted them to verify, without us involved, hey, go test our scalability. We want to know how well we scale. We think we know. And in fact, they proved it. What you can see here is as they added more virtual processors all the way to 64, you see almost nearly perfect linear scalability in a virtual machine. You simply won't find anything better than this. And this is because of all the tuning and work that we did to provide guest NUMA in a virtual machine. And why is this important? Let me be very clear. If we didn't do guest NUMA, you wouldn't see this. You would probably get up to about 8, and you would start to see it plateau, and you got to 16, you'd probably even see it fall down. Without guest NUMA, you don't get that level of scalability. So that's a bunch of work we did on the CPU, on the compute and memory side to make sure that we could give you massive scale up in terms of the virtual machine memory and compute resources. However, again, that's only one small piece of the puzzle. You've got to keep those compute and memory busy. So let's talk about I/O and storage. One of the things we heard over and over when it came to storage was, please, leverage my storage array capabilities. I have a quick question for anybody. If you don't mind, how many people in this room have a SAN or work with a SAN or own a SAN, SAN storage administrators? Yeah, pretty good number of you. Yep. So one thing that we heard repeatedly was folks that own storage and SAN arrays said, look, I've made a significant investment in this purchase. Is there anything you can do to better harness and leverage those capabilities? Okay, let's maximize your investment. Also, I need native access to my SANs. So this thing is running Fibre channel. Okay, I've got a big old scale-up workload here running SQL or Oracle or SAP or some CRM workload. And guess what? It's connected to my SAN via Fibre channel, and I need that native access inside the VM. Help reduce the cost of storage. So, you know, one thing I get asked about all the time is, what kind of SANs does Azure use? Who's your vendor of choice for Azure SANs? We actually don't use SANs in Azure. Azure is all direct attached storage. We need to scale in a very different way. And so the other thing to understand is, where is the cost in your data center? Storage is a big component of that. And we heard time and time again, people said, look, I have a SAN, but I have a bunch of resources and a bunch of workloads that don't necessarily require that. Are there ways that we can help reduce and be more efficient about my storage? And finally, big data. I've got big data everywhere, and I want to do more data analysis, and I want to do this inside of VMs. So I want scale-up VMs. I want access to my, native access to my storage, but I also need big access to big data. Today, virtualization platforms, doesn't matter who you are limited to 2 terabytes per virtual disk. Now, a long time ago, that didn't seem like a big deal. Now it's actually a very big deal. I talk to customers all the time that say, look, I got 1632 terabytes of data. It means I got a whole bunch of virtual disks I've got to manage, and I really would just not like to have to do that. So we heard you on that. So first thing we did is, with all that work we did in compute and all that work we did in memory, we took a very fine-tooth comb to the storage stack. Now, we've already had, up until now, we have one of the best performing storage stacks, period. In fact, if you look at some of the TPC benchmarks for SQL and databases, you'll see that Windows Server is in all of those. Windows Server leads the pack. So we already have an incredibly high-performing storage stack. Well, we went in and we even tuned it even further. And in fact, we actually set over 1 million IOPS from a single virtual machine. Now, just to put this in context, a few years ago, you'd need a cluster of servers to get 1 million IOPS. Now we're talking about out of a single virtual machine. Now, just to put this in context, I've actually looked within Microsoft. I've actually looked to see, do we have a workload in Microsoft that actually pushes this number? I found a couple of workloads that push about 250,000, and I found one that pushes somewhere between 425 and 450,000 IOPS. That's a massive database. Haven't found anything that's even remotely close to 1 million. So when I tell you I can virtualize anything confidently in Hyper-V, I'm not kidding. I can virtualize anything confidently in Hyper-V. We went from 2008 R2, where we support 250,000 IOPS, to way over 1 million now. The other thing I want to point out is that 1 million is not a Hyper-V limit. People ask me all the time, well, does that mean Hyper-V's hit its limit? It can't go any higher? Actually, no. That's as fast as the hardware would go. The hardware couldn't go any faster. Just to understand, this was a server filled with PCI, all of the PCI slots were filled with host bus adapters to my storage. And on the back end, I had tons and tons of SSDs. And guess what? They couldn't go any faster. And Hyper-V had plenty of headroom. It was barely even being taxed. So it goes back to my point. Hyper-V isn't your limiting factor. It's how much storage you want to provide us. So 1 million IOPS. So one of the other big things we want to do, like I mentioned before, was we wanted to leverage and harness the power of your SAN. One of the great new features in Server 2012 is offloaded data transfer. Now, let me be very clear about something. If you own a SAN, Windows Server 2012 is a no-brainer. It's like that. Just start installing this thing right now, because we did a whole bunch of work to make sure that SANs and Server 2012 are optimized for each other, and ODX is a perfect example. So let me explain to you what ODX does. Say, for example, I've got 10 terabytes of storage, and I need to copy 10 terabytes from one part of my storage to the other part of my storage. With Server 2008 R2, the way it works is I would read and write. Read and write. And I'll move to 10 terabytes. It'll happen. It'll take a really long time. It could take me hours or even days to move 10 terabytes. Okay? But that's how it's worked in the past. With Server 2012, it's different. With Server 2012, the first thing that happens is I go to the storage and say, do you support offloaded data transfer? Storage comes back and says, why, yes, I do. Fantastic. Here's a secure token. Please go perform that copy. Now what happens is the SAN gives me updates. I'm 10% through, I'm 20% through, I'm 50% through. And what's happening is on the SAN backend, it does the work for me. And in fact, in many cases, it may not even need to do the copy. It could literally be moving pointers. So instead of actually 10 terabyte copy taking hours or days, it can be done in minutes or even seconds. This is a crazy optimization. And quite simply, if you're looking at storage right now, and if you're looking at buying block-based storage, your first question is, does this support ODX? If the answer is no, stop listening. That storage, you're not going to be happy with that storage, because once you see ODX, you're going to say, why don't I have that? And the good news is, we've been working with all the storage vendors since very early on. And most of them have released it or are in the process of releasing ODX as a firmware update. So if you haven't gotten your ODX update, contact your storage vendor and say, hey, do you have the ODX update for Server 2012? So that's without offloaded data transfer. And with offloaded data transfer, it looks like this. Okay. Oh, there we go. All right. So one other thing to point out is offloaded data transfer is baked into Server 2012. It's simply an explorer. If you want to do a file copy, ODX just happens. And if your storage doesn't support ODX, that's fine. We'll do it the way we've always done it. It's transparent. It'll just happen. But if your storage does support it, then we'll take full advantage of ODX. In addition, Hyper-V is plumbed to take advantage of ODX. Here's one example. Creating disks. So if we want to create a fixed disk today, a 10 gigabyte disk, okay, the way we do it is we create a single file and then we zero it. And we do this for security purposes. Well, this can take a while. So in fact, I asked the storage team, I said, guys, how long does it take to create a 10 gigabyte file? And on a standard desktop, laptop machine, it takes about 3 minutes. I said, how long does it take on an ODX system? Oh, they said, oh, watch this. And by the way, don't blink or you may miss it. Click, done. Something that would take 3 minutes is done in less than half a second. That's how fast ODX is. We use it for all sorts of operations in Hyper-V, whether it's live storage migration, whether it's creating disks, whether it's expanding a dynamically expanding disk, whether it's merging snapshots. These are just all examples where we take advantage of ODX. Another big enhancement for 2012 in SANS, virtual fiber channel. I have to say, this feature has been received very warmly in the industry. Virtual fiber channel is exactly what it sounds like. With virtual fiber channel, we actually create a virtual fiber channel adapter in the VM. And let me be very clear, it's real fiber channel. This is real, honest-to-goodness fiber channel. This isn't some emulated or something random. No, this is honest-to-goodness fiber channel going into the VM. It uses NPIV functionality, which has been around, endport virtualization for virtual fiber channel. It's been around for quite a while. And we're taking advantage of that and exposing fiber channel into a virtual machine. From a support standpoint, it does require Windows Server 2008 or later inside the VM. And of course, the host has to be Server 2012. Keep in mind, if you have an existing NIC today that worked on Server 2008 R2, a fiber channel adapter, and it worked on 2008 R2, just make sure that the drivers exist for 2012. I've had a number of people say, hey, I had a fiber channel adapter that worked great in 2008 R2, and now I want to use it with 2012 with Hyper-V. The key is the driver has to have support for it. There have to be 2012 drivers because we added a couple of calls to make this work. In addition, and the big one, is live migration just works too. This goes back to something you told us early on. Don't give us a new feature and preclude live migration. In fact, one of the questions I would ask is I would talk to a customer and I'd say, look, I have brand new feature X. Feature X is really, really cool. But if I give you feature X, this VM is locked to this server. I can't live migrate it. I can't storage migrate it. I can't cluster it. I can't do anything. It is it is strapped to this machine. How do you feel about feature X? The answer was always the same. We want you to shoot feature X and we want you to never talk it about again, okay? Because I always have to be able to live migrate a VM. That is not even negotiable. And so when we did virtual fiber channel, we had an interesting engineering challenge. How do you do this in a way that keeps all of your fiber channel best practices for zoning and masking, and how do we do all that and make live migration work? Well, we came up with a very interesting way to do this. With virtual fiber channel and live migration, when you go to configure fiber channel for a Hyper-V VM, you'll notice there's actually two sets of addresses. You've got your worldwide node names and your worldwide port names, just like you would on a physical machine, except we provide you two. And the reason why is because you need to have access to both the source and the destination to perform the live migration and to be able to do it without interruption. If you try and do this with one, you're always going to see a blackout because as fast as fiber channel is, it cannot do the cutover fast enough to do it live. So how does virtual fiber channel work? Well, like I said, you've got two sets of port names on my source. I've got two on my destination. So we create a temporary VM on the destination server. We connect the temporary VM's host bus adapter to the second set of addresses. We verify that it has connectivity to the shared storage. We make sure we do a pre-flight check before we do the live migration. We make sure that we have connectivity, we have all the right resources. Once everything passes the pre-flight check, then we're going to start the live migration. When we do that, we're going to do the way we do a normal live migration. We're going to move all of the memory state over. We're going to get that memory state to as small as possible. Then finally, we move that last memory state over. We can do it very quickly without dropping any pings. And that's when we change the worldwide port names and node names on the virtual fiber channel to the target and keep running. And once we begin on the new destination, then we delete the virtual machine and all of the connectivity that we had on the source. And so we made sure that live migration continues to work, continues to function, and you get the best of virtual fiber channel. And as I mentioned before, this is real fiber channel. So if you want to do guest clustering, if you want to use MPIO software, if you want to use DSM like EMC PowerPath, it all just works. So you get all the benefits, no trade-offs. A couple of tips. Since a lot of people have been trying fiber channel, I realized I wanted to make sure there were a couple of tips here. Number one, remember, it requires Windows Server 2008 and later for the guest OS. Okay? Doesn't work on 2003. 2003 has a very different driver model. 2003 is near the very, very, very end of its support. Please, please, 2003 is just about done, folks. Make sure you're already working on the new stuff. Great time to be deploying 2012. Verify that you've got the latest drivers and firmware for the fiber channel adapter. Okay? Just because you had a fiber channel adapter that worked with 2008 R2 doesn't mean it's going to guarantee to work with 2012. You need the driver support, and do check the firmware, because a lot of the vendors upgraded their firmware, even up to very recently, for changes in 2012. Another one, we need NPIV. This is crucial. Okay? The way virtual fiber channel works is it takes advantage of a capability of virtual fiber channel adapters called NPIV. It has to be enabled on the fiber channel adapter. If it's not, you're going to get an interesting error in Hyper-V that says, hey, it looks like fiber channel is not available for this HBA. The other one, and the trickier one, this is the one that most people are missing, is that NPIV has to be enabled on the fiber channel switch port. So a lot of people are getting it on the host bus adapter, and then you get this error in Hyper-V that says it looks like the fiber channel fabric doesn't support Hyper-V. Well, that's generally our clue that NPIV hasn't been enabled on the fiber channel switch port. Very often, it's not. And you have to check on a per switch port basis. So if you follow those four things, lots of goodness is going to happen. So there's your tips for the day. When it comes to storage, huge changes across the board. Number one, we now support Hyper-V VMs on file-based storage. We did this to reduce the cost. So if you want to create a 2012 file server, stick your VMs up there, and instead of using, an expensive SAN, you can put it on a file server, and it runs great. Guest fiber channel is here. Big one, the virtual disk format. That is not a typo. We now support up to 64 terabytes per virtual disk. Not per VM, per disk. For those wondering, we still support up to 255 disks per VM. So if you do the math, that's roughly 16 petabytes of storage per VM. So you're going to run out of physical storage long before you run out of virtual storage. So we got you covered there. In terms of guest clustering, you've been able to do it via iSCSI for a number of releases, but now you can do it via fiber channel as well. We have native 4K disk support. As the industry is starting to move and changing the disks that are out there, one of the things that's happening very quietly is we're moving to native 4K disks. Server 2012 and Windows 8 and Hyper-V are the very first releases of Windows that support native 4K disks, so you're going to want that going forward. I already talked about secure offloaded data transfer, and also I should also point out that merging disks now is all live. So if you're a tester or developer and you like to play with snapshots, snapshots are really cool. In the past, when you needed to merge those snapshots, it required downtime. That's all hot now. You don't need to take your VM down at all. You can do all of those while the VM is running with simply no downtime. And if you're interested in knowing more about the SMB3 protocol, offloaded data transfer, the new VHDX format, you guys will have access to my presentation later. Those are all the links there. So, Windows Server 2012, networking and software-defined networking. It's really interesting to see what's been going on the last 12 to 18 months in terms of software-defined networking, software-defined data center. Everyone's talking about software-defined networking like it has never been done before, like it's something that is completely brand new and no one's ever thought of it. It's interesting to see what's going on here. We actually knew from running our own data centers, Outlook, Bing, Xbox, Hotmail, we know that to run at this massive scale, you have to have a software-defined networking solution. So before I jump into that, one quick sidebar, NIC teaming. This is one of my favorite new features in Server 2012. One thing we find is generally when you buy a server, it comes with, say it comes with vendor A on the motherboard, and then you decide you want to add another NIC to add some more network connectivity. So you put in vendor B. And what ends up happening is, well, you want to team these together, and then you can carve it up in software. Except vendor A doesn't support teaming to vendor B doesn't support teaming to vendor A, and the guy you purchased the server from says, no, I'm not going to support any of that. So what ends up happening is you have these siloed NICs. The motherboard is running, you know, maybe your management, and your PCI cards are running something else. And what you really want to do is you want to combine all of these. With Server 2012 and Team NICs, you can absolutely do that. In fact, if you want a team from different vendors, go right ahead. One of my colleagues in the networking department, networking team, has a server with 12 different NICs from 12 different vendors, all in the same server, all teamed, and it all just works flawlessly. You have a problem, you call us. Okay? We got it all in the box, and it works fantastic. Now, when it comes to multi-tenancy, there are a lot of interesting challenges out there. And we heard both from enterprises as well as cloud service providers out there. They said, quite simply, we need help. The way we've been doing this in the past is VLANs. VLANs are a nightmare. I have now talked to two different cloud service providers who've told me the same story. They basically went out and bought some switches. Now, according to the VLAN spec, there are 4,095 VLANs per the spec. Unfortunately, in two different cases, these cloud service providers got a good deal on these switches, but these switches only supported 1,024. One of them had over 900 customers, the other had over 1,000. Guess what was about to happen? Really bad things. They realized we've hit the wall. And basically, they end up spending a lot of money, time, and resources pulling out the old ones, dropping in new switches, and wreaking havoc on the network as they tried to move from one set of switches to the new one. And fundamentally, it still didn't solve their problem. Because eventually, if business continues to boom, they're going to hit the 4,095 limit as well. So you got some real challenges when it comes to VLANs and logical segmentation. On the one hand, you've got Woodgrove Bank here and Contoso Bank. And in fact, they both want to go to a cloud service provider. But you notice they're both using the same IP address. How do you change this? How do you fix this? And in fact, the tenant wants to easily move to their VMs to the cloud. And in fact, hey, if I'm the service provider, I want to make it really easy for them to come to the cloud too. Okay? We all actually want the same thing. We want easy onboarding, flexibility, and isolation. The way to do that is network virtualization. With network virtualization, we're essentially applying the properties and principles of machine virtualization to network virtualization. So for example, today, with a virtual machine, you've got a physical piece of hardware, and we got these virtual machines. And these VMs have virtualized hardware. It doesn't look anything like the physical hardware. Physical hardware could have, you know, a bunch of PCI sockets, a bunch of DIMM sockets. It's got specific NICs. But inside a VM, you see virtual network adapter. You got virtual memory. You got virtual processors. And because we've decoupled the virtual machine from the physical hardware, I can live migrate it. I can move it around. I can snapshot it. I can clone it. I can do all sorts of interesting things because I virtualized the whole machine. Well, let's do the same thing with the network. Today, you've got a physical network, and it has an IP address. Great. Let's virtualize the network. So now we're going to create logical networks on top of the physical fabric. Okay? What this means is I can create these logical networks that live on top, okay, and I'm going to use industry standard technology, NVGRE, to do the virtualization. And let me be very clear, NVGRE is an industry standard. This isn't some Microsoft-only thing. No. In fact, it's been out there for quite a while, and it works with all of your existing switches. It works with all of your existing routers. It works with all of your existing NICs. That was a key tenet. What's nice about this is, number one, you don't need VLANs anymore. I can literally have a blue network and red network, Contoso and Woodgrove, could literally be on the same physical server with the same exact IP address. Two VMs, 10.0.0.1, 10.0.0.1 on the same physical machine, and they can't see each other. There's no collisions. They can see all their east-west traffic, they can see all their north-south traffic, but they can't see each other because they're logically segmented through network virtualization. In case you're wondering, the official specs are right here, so if you're interested in knowing a lot more about NVGRE, it's all right here. But what's nice about this is it actually lowers the burden on the switches, because all of this is actually handled, allows for better traffic analysis, metering, and control, but this is handled at the server side. So there's a tenant network address and a MAC header. Essentially, you're keeping track of, yeah, I've got a physical host that has a physical, what we call the provider address, but the virtual machine has its own, what we call, that's the tenant network address. So I can continue to move VMs around, and I can even live migrate across physical subnets. So if you saw my keynote this morning, you saw me do exactly that. I can live migrate across physical subnets because I've decoupled the virtual logical network from the physical fabric. Another key part of software-defined networking is the extensible switch. So we look at software-defined networking as having really two very key components for us. One, network virtualization, and the second one, this extensible switch. And we actually had a lot of debate about the extensible switch at Microsoft. Because if you look at how the other guys did it, basically VMware has really a closed replaceable switch. With VMware, you can use their switch, or you can replace it with the Cisco Nexus 1000V, but it's one or the other. That's how you kind of do it. We certainly could have done that. We had a lot of debate about it, and a couple engineers were like, look, that's easy. We can do that a couple days and call it a day. I mean, it's really pretty easy. But we decided after a lot of debate about this, we said, no, we actually want to do something a lot more intriguing than that. We think there's a lot of value in the virtual switch. And so we want to make it open and extensible. So what do I mean by that? Well, say, for example, you just want to inspect traffic as it goes across the virtual switch. And you can see here, I've got a couple of VMs, and basically those virtual NICs go down here through the virtual switch, through the network stack, down to a physical NIC. Well, you can see here at the very top, I've got capture extensions. Those capture extensions, very simple. If I just want to inspect traffic and generate traffic for reporting purposes, well, SFlow by Inmon is available today to do exactly that. If I want to do something more interesting than that, I want to drop packets, I want to insert packets, I want to filter packets, I want to modify packets. This is the perfect place for intrusion detection. This is the perfect place for anti-malware. This is the perfect place for firewall. In fact, our friends over at Five9 have delivered a virtual firewall that plugs right into the Server 2012 extensible switch. And we got other partners that are plugging in here as well. This is all built on the Windows filtering platform, WFP. This is very, very rich semantics to do all sorts of interesting stuff. Finally, we've got forwarding extensions. So if you do want the Cisco Nexus 1000V, lo and behold, this is where they plug in. And in fact, on top of that, NEC just announced and has released it already, the NEC programmable OpenFlow switch for Hyper-V. And in fact, that was the first platform they delivered it on. For them, it was the easiest, and it's available right now. So we've seen a lot of interest in OpenFlow, especially in Europe and Asia Pacific, and it's available right now today for Hyper-V. Now, what's great about this solution is you can mix and match. Like I said, with the other guys, it's a one or the other proposition. Well, what if you decide, you know what, I really like SFlow. I'd like to be able to do I'd like to be able to capture and do some reporting and use that, but I'd also like to take advantage of the Cisco Nexus 1000V. You can use them together, in tandem. That may make sense for your data center. What happens if you're in a branch office? Okay, maybe the Nexus 1000V is overkill in the branch office, but what you really would like is a firewall. Well, guess what? You've got the Five9 firewall, plugs right in for branch office, and you can mix and match based on your business needs. Finally, you may look at this and say, you know what, Jeff, this looks really cool, but I've got something really unique. I do something very interesting in my infrastructure that probably nobody cares about. Is there a way that I could plug into this? Yes, you can write your own extensions. We made this open and extensible. So if you look at this and say you want your own solution, write your own extension into the switch. On top of that, Hyper-V is built into Windows 8. That's right, Hyper-V, the real deal, is built into Windows 8. So if you want to develop your own switch extensions on your laptop or your tablet or your desktop and deploy those on server, you can. Because everything you create on Windows 8 is fully compatible with Server 2012. So we've given you a great solution there as well. And when it comes to networking, really rich solution here. We've got a lot of capabilities. In fact, I'm going to switch on over so I can point some of those out to you. So where's my mouse? There it is. Whoops, that's what it was looking for. That helps if you, there we go. All right. Let's go on over here to a VM and take a look at some VM settings. So as I mentioned before, one of the goals that we had with virtual networking in Server 2012 was to provide a really rich networking experience. Ooh, sorry, don't mean to, there we go. So let me hop on, click on the network adapter. First of all, you'll see that there's actually a whole bunch of options here. We didn't have these back in Server 2008 R2 and previous. In the previous versions of Hyper-V, the virtual switch was a fairly simple switch. It was, think of it as an unmanaged switch that had VLANs for logical segmentation. And it worked for a good chunk of users out there, but as we move to the cloud and more mature deployments and being able to do network virtualization, we wanted to do a lot more. And in fact, while we designed extensibility into the switch itself, we wanted to make sure we provide a really rich switch, even using the built-in capabilities. So earlier today in the keynote, I talked about bandwidth management and quality of service. We now have quality of service built in. You can set minimums and maximums very simply, very easy. Let's go on to the next tab, though, hardware acceleration. We did a number of things here to carefully go up here. There we go. To be able to improve network virtualization performance. Or, I'm sorry, virtualized networking performance. So this basically improves all of the performance for your VMs. One of them is VMQ. VMQ is something we like a whole bunch. Virtual machine queue is an offload that allows us to basically avoid a whole bunch of copies inside of the virtual switch and allows us to shortcut getting packets from the physical NIC into the virtual NIC for the VM. And allows us to avoid a whole bunch of copies that we have to do in terms of the switch and a whole bunch of packet processing we do there. By default, you can see VMQ is enabled. So if you drop in a NIC or using a NIC that has VMQ, we'll automatically take advantage of that. Another area is security. You notice up here, we have this feature called IPsec task offload. One thing that we're seeing is people want to do more and more end-to-end encryption on the wire. Now, if you wanted to do that, IPsec is a great way to do that. Transparent, you don't have to do anything to your apps, end-to-end. Now, in the past, you can use IPsec with Server 2008 R2 Hyper-V, but we'd have to do all the encryption and decryption in the virtual machine. Now, it's not really expensive. It's a percentage point or two. But when you add that to every virtual machine, if you've got 10, 20, 30, all of a sudden, that adds up pretty quickly. And you're taking a good amount of overhead to do all this encryption and decryption. So in Server 2012, if your NIC supports IPsec task offload, we'll actually offload that to the NIC for us. It does all the work. You still get your encryption and decryption, except now we're getting it for free. If your NIC doesn't support it, we'll do it in software the way we've always done it, but it's in there and it's on by default, so you can take advantage of that capability. Single root I/O virtualization, SRAOV. So one thing I mentioned before is people wanted us to be able to virtualize any workload. Now think about that really big monster workload. You've got that server over here. It's got dozens of cores, hundreds of gigabytes. It probably has two 10-gig NICs in there. Okay? Those two 10-gig NICs, they're teamed. They're doing LBFO. And the reason why is because you've got some application that has low latency, high throughput requirements. Now you want to take that and move it into a virtual machine. How are you going to satisfy that requirement? And when I mean high performance, I mean greater than 10 gigabit performance. Okay? Because if you need less than 10, I can give that to you with VMQ, not a problem. With VMQ, I can easily get you up to 9 gigabits, no problem. But if you want more than that, if you really need full 10 gigabits or more, then you're going to need something even better. You're going to need SRIOV. With SRIOV, we actually map the network adapter, a portion of the network adapter, into the VM. Now think about that for a second. You're actually seeing a portion of the NIC inside the VM. So if you go to Device Manager, you don't see the Microsoft Virtual NIC anymore. You'll see, oh, this is an Intel NIC, actually in the VM. And what we're doing is we're bypassing the switch. We're talking directly to the NIC. So if you want to get 10 gigs plus into a VM, we can absolutely do it. So SRIOV is designed to do that. Let me go over here to advanced features. We have one more set of tabs. So we added some security features as well. The first one we've had for quite a while. This is enable MAC address spoofing, and I'll explain what that means in a second. But we added two new security features, DHCP guard and router guard. One thing I like to remind people is the bad guys have credit cards too. If I'm a bad guy and I want to go up to a service provider, I can get a VM really, really cheap, and I can pretend to be a DHCP server. I can pretend to be a router, because I want to try and see if I can actually spoof and find any packets on the wire and see what's going on out there. I want to break outside of my logical segmentation and see if I can do that. So if I can pretend to be a DHCP server, which are notoriously not the most securest things in the world, or pretend to be a router, maybe I can go fishing and find some packets out there. So you can enable DHCP guard and router guard that will actually drop DHCP server messages and router advertisements. In addition, for developers and for folks that are trying to do debugging of the network, port mirroring is something that people have asked for. So if you say, for example, you want to be able to look at some network packets. So you want to, in a physical world, you'd actually go take a look at that. You'd say, hey, please mirror those packets to this port so I can take a look at what's going on here. We can do that in the virtual switch as well. Very often people ask me about promiscuous mode. Technically, that's not the right thing. Port mirroring is really what you're asking for, because you want to be able to look at packets. So you can set a destination, you can set a source, and you can look at all those packets. Finally, you notice we have NIC teaming. Now you may be wondering, oh, he mentioned NIC teaming before. Well, this is actually a different flavor of NIC teaming. We do NIC teaming in the host, but this is for NIC teaming in the guest. So why would you do this? Well, think about that scenario I just gave you. You have that big scale-up workload. It's got two 10-gigabit NICs that you're using LBFO, that you're teaming already. Now you're going to take that, you're going to virtualize it and put it in a VM. You're going to use SRIOV because you want to get raw, as close to the metal performance as you can. You want to get line rate. But you still want to take advantage of LBFO. You're not going to give that up. Okay, I'm not going to take this workload that was running on physical, put it in a VM and give up LBFO. That's not happening. So you have to make sure that you can provide teaming. So when you do that, you need to come in here and check this checkbox. Now, let me explain to you what this checkbox does. You've got NIC teaming and you've got MAC address spoofing that are actually very similar in what they do. Let me explain what they do. MAC address spoofing is for network load balancing. Okay? If you've got a VM, two VMs, and you want to put a load balancer in front of those, the way load balancers work is they mess around with MAC addresses. They alter those. They modify those. Okay? To do that, you have to enable MAC address spoofing. What MAC address spoofing allows you to do is for your NLB software to be able to change the MAC addresses on virtual NICs from different VMs. Okay? Now you have the one at the bottom, which is NIC teaming software. NIC teaming software does something kind of similar in that it plays around with MAC addresses as well. The difference is with NIC teaming, it's playing with MAC addresses for two NICs on the same VM. Okay? So MAC address spoofing is for being able to manipulate MAC addresses on different VMs, whereas NIC teaming is to enable MAC address manipulation on the same VM. So that's the difference between the two. And make sure that if you are doing guest teaming, you have to enable this. Otherwise, it may look like it's working, but it's not, because it's not actually manipulating the MAC addresses, because it can't. So I can see I'm already running very, very short on time. So I'm going to switch back on over here. Okay. Okay. All right, let me switch on over and discuss some important changes in HA. I already mentioned earlier we made some huge advancements in terms of scale. 64 nodes, 8,000 virtual machines in a cluster. By the way, one thing I always get asked, Jeff, if I want to do 8,000 VMs in a cluster, do I have to have a 64-node cluster? Technically, no. We support up to 1,024 VMs per server. So if you wanted, you could actually make an 8-node cluster and do 8,000 VMs. I would never recommend that because your fault domain is insanely high. In fact, the reason why we support 64 nodes is so we can better disperse the VMs across the cluster and reduce the fault domain. So just to let you know, that's what that is. We made some big changes in failover clustering. We now have prioritization. So for example, if you're in a failover environment where you've had catastrophic case, maybe you've had a power outage go out in a server or something has gone down, but you've had some servers go down, when those virtual machines fail over, you can assign a priority to them. So for example, my domain controller, very important, that's probably going to be high. My SQL server, very high. Print server, who cares? That can be really, really low. So you can put business rules and prioritizations with those VMs. Another thing is we have enhanced failover placement. So we actually take into account things like dynamic memory, NUMA, in terms of placement of VMs in terms of failover. I also want to point out node maintenance mode. So the clustering team did some really, really awesome things in 2012. Think about this. I got a server. It's a node in a cluster. I need to take it down because I need to add a disk, or I need to upgrade some memory, or I need to do some physical maintenance on the machine. Okay, so in the past, you would go in there, you'd fire up failover cluster manager, and you'd start draining resources. Now it's a right click. Now you just say, look, just drain all the roles. And this can be Hyper-V VMs, or it can be any other role that's clustered. But for Hyper-V, it's fantastic. We just live migrate them off. When you drain the roles, then you can take the server down. Once the machine's drained, it notifies the cluster, this machine is out of service right now. We're going to do some work on it. I can take it down. When I'm done, turn it back on, bring it in the cluster, say, OK, I'm back on, fail the roles back, and it'll automatically live migrate the VMs. So that's really awesome. But then they took it another step further. This is a big one. Cluster-aware updating. Think about this one. You got a 16-node cluster, and you've got to perform a patch. And you need to patch every node in the cluster. Today, the way that would work is you'd go to node 1, you'd make some changes, maybe you've written some custom automation or something like that, but essentially you're going to drain all of those resources, and patch each one of those. In Server 2012, I can now patch the entire cluster with a right click. Okay? With cluster-aware updating, it's literally, hey, let's go patch the cluster. It will go to node 1. It will live migrate the VMs off. It will install the patches. It'll reboot the system, bring it back online, move to node 2, live migrate the VMs off, and literally walk through every node in the cluster for you. In fact, if you want, you can schedule this. Say, you know what? Every last Friday of the month at 7 p.m., go patch the cluster, please. It'll do all the work for you. And if you want, there's a big patch it right now button. Update the cluster right now, and you can sit back and watch it. So we made some huge advancements in making sure that clustering management is much, much easier. So one question I get asked all the time, Jeff, we're building a cloud. And you know what? I hire really good people. Okay, I do background checks, or I've known these people for a very long time, but I'm really worried about the whoops moment. The, hey, we thought we had something locked down and something went out the side door and we just lost a whole bunch of data. Do you have any processes in place other safeguards to help me protect my data? Well, let me give you one example. There was a HIPAA breach this last year. In March 2012, a large medical provider in Tennessee is paying $1.5 million to the U.S. Department of Health and Human Services. What happened was they had 57 hard drives stolen. Think about this. This contained protected health information for over 1 million individuals. I can't think of anything more private than my health history. In fact, what even makes me madder is, what if this was my daughter's health history? It's one thing, it's mine. It's even, I get super protective about my two daughters. I can't even imagine something like that happening. And in fact, this company actually made the argument that they shouldn't be fined at all. They said, look, we had this thing secured. We had security patrols going around the building. We had a biometric scanner to get in the building. We had a key card scanner to get in there. We had magnetic locks. We had keyed locks. In fact, you shouldn't fine us a penny because look at all this work we did. And the answer from the U.S. Department of Health and Human Services was, actually, we would fine you more if we could. This is as much as we're allowed to. Because while you did all of this stuff, the data got out. People's most private and protective data. And in fact, 71% of healthcare organizations have suffered at least one data breach within the last year. We want to make this better. That's why with Server 2012, we've introduced a really critical component for cloud, which is BitLocker encrypted cluster volumes. First time ever, you've never been able to do this. We've had BitLocker for a number of releases, but it's always worked with direct attached storage. So for example, when military goes into combat, for example, the US military, their servers, they're all running BitLocker. So if I have to make a hasty retreat, standard operating procedure is to take a grenade, put it on the server, and run that way. And if the grenade takes out the server, fantastic. If the grenade doesn't take out the server, it's still okay. Because the bad guys pull out the disk, the only thing they can do is type in the PIN or format the disk. That's it. That's your options. Well, that only worked with direct attached storage until now. In Server 2012, you can now create the biggest, baddest clusters in the industry, 64 nodes, 8,000 VMs, but do this all on clustered shared storage, and it's all encrypted. This all works with Active Directory. This integrates with group policy. This integrates with clustering. This integrates with Hyper-V. This all just works. On top of that, I get asked very often, is there a performance impact? If I turn this thing on, is my performance just going to go down the tubes? No. In fact, we had to put in special instrumentation to find it. It's actually less than 1%. That's because we're taking advantage of the latest capabilities and processors and storage out there to do encryption. We think this is a critical capability when it comes to the cloud. Finally, complete VM mobility. This goes back to your favorite topic, live migration. So in Server 2012, again, customers told us, don't provide new features that preclude live migration. If you do, we're simply not going to use them, we're simply not going to care, and honestly, you're going to make us really mad. So, in fact, do the opposite. I want to be able to securely move a VM or any part of a VM anywhere at any time without limitations. Whoa. That's an incredibly difficult engineering challenge there. In fact, the gauntlet was thrown. We really want to be able to move VMs without any limitations. We want no downtime servicing. I want to be able to do SAN upgrades and migrations, move all my historical data, and fully leverage the hardware to speed any migrations. Lots of requirements around this one. So that's exactly what we did. The first one, live migration with HA. Now, we've had this for a release or two, and in fact, the way it works is you create a cluster, and this gives you a solution for planned and unplanned downtime. I can live migrate VMs between nodes in a cluster. I can walk up to a server, yank out the power cable, and the VMs will automatically restart on other cluster nodes without a user intervention. However, one of the big changes is concurrent live migrations. In Server 2008 R2, you could do one live migration at a time. In Server 2012, there is no limit. The only limit is how much hardware you bring to the party. For example, if you've got gigabit Ethernet, I can probably do 2, maybe I can even do 4 live migrations simultaneously. If I've got 10 gigabit Ethernet, I can easily do 10, maybe even as high as 20 live migrations simultaneously. If I've got dual teamed 10 gigabit, I can easily do 40, as high as 80 live migrations simultaneously. The question is, how fast and how much hardware are you bringing to the party? Hyper-V has no limitation. What's great about this is it future-proofs you as you go forward. Because 10 gigs here, we've been waiting for the port prices to go down on the switches, and it's happening. But 40 gigs on the runway, and people are already talking about how do we get to 100 gigabit and terabit. Well, guess what? Hyper-V is ready to go right now. On top of that, we now support SMB live migration, meaning you can put a live migration now up on an SMB file share, which dramatically lowers your cost. You don't need a SAN infrastructure anymore. And in fact, you don't need clustering. If you say are in a test dev environment and you just want to put your VMs up on a SMB file share, you can do that and you can live migrate your VMs around in a test dev environment. Now, you may not care about HA and high availability. If you decide later you do want high availability, enable clustering and you get that as well. And finally, we enable live storage migration. So live storage migration is where the VM sits in place on a server, but you're moving the VM storage from one location to the next. And again, we support concurrent live storage migrations, again, only limited by the hardware. Of course, when we went back to your initial requirement, which is, Jeff, we want to be able to move any part of a VM anywhere at any time, well, that's kind of laying down the gauntlet. In fact, it goes to the holy grail of virtualization, which is, wouldn't it be great if you could live migrate a VM with nothing but an Ethernet cable? I mean, no shared storage, no SANs, no clustering, literally server 1, server 2, Ethernet cable, that's it. Well, that's exactly what we did. The first ones to bring it to market, shared nothing live migration. Shared nothing live migration is literally that. It is literally, I've got a machine here, I've got a machine here, and nothing but an Ethernet cable. I'm in Redmond, I'm in building 43 at Microsoft. I'm on the first floor. I live migrate a VM up to the third floor, down the street to building 25, down the street to building 9, back to building 44, over to building 42, and back to my office, all over Ethernet. Never touched a SAN. It's awesome. Let me show you. By the way, I know that I'm way over time. Sorry about that. If you'd like to leave, you won't hurt my feelings. I promise I'll finish in just a second. Let's head on over to shared nothing live migration. All right. Where's my mouse? Oh, there's my mouse. Log me out again. In case you're wondering, by the way, I'm doing all of this through RDP, all of this through Remote FX. This is all running in Redmond, so pretty excited about how well this has all been working. I'm just going to live migrate a VM. I'm just going to pick one over here. I'm going to right-click on it. I'm going to click on Move. All right. You'll see I've got a couple of options here. I can move the virtual machine, which is the virtual machine in its entirety or a specific component of it, or I can move the virtual machine storage, which would be live storage migration. In my case, I want to move the VM. It's going to ask me, okay, give me the name of the server. And whoops. Let's try that again. And I'm just going to pick a host here at random. Now it asks me, do you want to move the virtual machine to a single location? Would you actually like to choose? So here's something a lot of people don't realize. We got super granular with live migration. Say, for example, I wanted to live migrate. It had 3 different disks, and I wanted to live migrate one to a file share, another to a different direct attached storage, and the third one to a SAN. I can actually do all of that simultaneously. Multi-target live migration. It's actually all in the box. It's here as well. Now, I'm going to keep this really simple. I've just got a single VM, and I've just got a single disk attached. And now it's going to ask me, where do you want to put it? So I'm going to click on Browse. Select a folder here. Yeah, let's go with that. Let's click that. Let's click on Next. And you can see there's everything we just did. Walked you through a wizard. Oh, I'm going to try and click on Finish, except I'm going to go right past it. Sorry, let me just get out of magnification mode. Let me go back over here. And let me click on Finish. And what's happening here is a shared nothing live migration. A lot of people ask me, okay, how are you doing this? What sort of magic is involved? Is this safe? Is this HA? Is this not HA? Should I not be doing this? When should I not be doing this? Let me be very clear about shared nothing live migration. Number one, it is not HA. Never said it's HA, and it's not designed to be HA. It's mobility. What this allows me to do, first of all, there's no shared storage. There's no shared infrastructure. This is all happening over the network. In fact, I chose a pretty big VM, so this is probably going to take a while. This is a VM I believe has somewhere around 15 gigabytes of storage, but it's all happening over the network. So number one, this is not HA. Okay, if I go up and yank out the power cable on this server, that VM goes down. If you need HA, enable clustering. What this does give you is all sorts of new mobility scenarios that were never possible before. For example, today, if you've got a cluster and that cluster gets full, what do? You go set up a new cluster. Now you need to somehow move VMs from that first cluster to the second cluster. Without shared nothing live migration, there's no way to do this because you don't have a shared infrastructure involved. With shared nothing live migration, I can live migrate into a cluster, I can live migrate out of a cluster, and I can live migrate between clusters without any downtime. So that's one of the beauties of shared nothing live migration is it gives you these new mobility options. The other question is, how does this work? Let me explain it to you in detail. Shared nothing live migration takes advantage of a number of key technologies that are in Server 2012. The first thing we do is we move all the storage. So we do a live storage migration. So the first thing we do is we look at all of the on-disk representation for the VM. We look at all of the virtual disks, we look at the configuration files, we look at all of the on-disk representation, and we move those over. We start copying those over first. What we do is we get all of those copied over to our destination. We then put the VM into essentially an I/O mirroring mode. We're actually writing to both locations simultaneously. And the reason why we do this is because we have to make sure that if any time during this shared nothing live migration something happens, like the destination goes away, we've got to make sure that your VM continues to run. We always make sure that your VMs are never at any risk or in any peril. So they continue to run on the source while we move all of the storage on over. So move the disk configuration file, and then we go into an I/O mirroring mode. Once we do the I/O mirroring mode, we now start to move the running state. So that consists of the memory state of the virtual machine. The VM could, say, have 4 gigabytes of memory assigned to that. Of that 4 gigabytes, probably only a small portion of that is actually in use. Say, for example, 4 gigabytes, but maybe only 50 to 100 megabytes is actually active. So what we start doing is we start transferring and copying all of those pages over the network as well. Finally, we get that to this very small kernel of what's actually running, the actually active state. Once we finally get to that last bit of active state, we'll quickly brown it out and move that remaining state over, move all of the storage state as well, and begin running on the new target. Once we begin running on the target and we can successfully begin executing over there, then we go back and delete everything on the source. We don't do that until we successfully have moved to the new target, because up until that point, if anything happens, we want to make sure that we can always continue to run and your data is never at risk. So that's, in a nutshell, how we solved an incredibly difficult engineering problem. And through all of that, we made sure that every single new feature in Server 2012 Hyper-V works with live migration. Virtual fiber channel, SRIOV. I should point out that the other guys offer SRIOV. It doesn't work with live migration. They haven't solved that problem yet. Ours does, because one of our core engineering tenets to you was we weren't going to release a product that had features that precluded live migration. So every single new feature in Server 2012 works with live migration. Oh, and I actually wasn't keeping track, and the VM is done. That is how you do a shared nothing live migration. So with that, I am way, way over time. My apologies to you, and my sincere thanks for being patient. I hope you guys have a wonderful Tech Days. Please take a look and take a look at the fill out the forms. Love to hear your feedback. It's been an absolute pleasure to be here in Finland. I'll be out here at the party. If you have additional questions, would like to ask me about cloud or Hyper-V or anything, I'd be happy to answer those questions. Thank you very much, and enjoy the rest of your time here at Tech Days.